Welcome to another episode of Networking. Today, we'll delve into the fascinating world of networking, specifically focusing on the transport layer and its crucial functions, such as multiplexing and demultiplexing. We'll also touch upon TCP versus UDP, the three-way handshake, and the role of TCP flags. And finally, we'll explore how firewalls enhance network security. So, let's get started. In computer networking, the transport layer plays a vital role in ensuring reliable communication. One of its standout features is the ability to multiplex and demultiplex traffic. But what exactly do these terms mean? Multiplexing is the process of directing traffic from multiple sources to various receiving services. It enables nodes on a network to efficiently use the available resources. Demultiplexing, on the other hand, occurs at the receiving end. It involves taking incoming traffic aimed at the same node and delivering it to the appropriate receiving service. Now, let's dive into how multiplexing and demultiplexing work. Multiplexing and demultiplexing are achieved through the use of ports. A port is a 16-bit number used to direct traffic to specific services running on a networked computer. Imagine a server as a program waiting to be asked for data, and a client is a program requesting this data. Different network services run while listening on specific ports for incoming requests. For example, HTTP, the protocol for unencrypted web traffic, traditionally uses port 80. So, if you want to request a web page from a server at IP address 10.1.1.100, you direct traffic to 10.1.1.100 to 80. To better understand the transport layer, it's essential to grasp the differences between TCP and UDP. TCP is connection-oriented and provides reliable data transmission. It's like a phone call where you ensure that the other person hears every word you say. UDP, on the other hand, is connectionless and provides faster but less reliable data transmission. It's like sending a postcard. You send the message, but there's no guarantee it will reach its destination intact. When establishing a connection using TCP, a process called the three-way handshake is crucial. Let's break it down. The three-way handshake involves three steps: SYN, SYN-ACK, and acknowledgement. This process ensures that both the sender and receiver are ready to exchange data. TC flags play a significant role in this process. Flags like SYN, ACK, and FIN are used to signal different stages of the connection. Finally, let's discuss how firewalls enhance network security. Firewalls act as a barrier between your network and potential threats from the internet. They filter incoming and outgoing traffic based on predefined rules. Firewalls help protect your network by blocking unauthorized access, preventing malicious activity, and ensuring data integrity. That concludes our exploration of the transport layer's essential functions, including multiplexing, demultiplexing, TCP versus UDP, the three-way handshake, TCP flags, and the role of firewalls in network security. We hope you found this video informative and helpful. If you did, don't forget to like, share, and subscribe to stay updated on all things networking. And as always, feel free to leave your questions and comments below. Thank you for watching, and we'll see you in the next episode of Networking.